Hello and welcome back. We are in part 2 of chapter 3 talking about central tendency. But now we're shifting gears because we're going to start talking about the spread or the variability that your data has. So we're going to get there by talking about skewness. So skewness we talked briefly about in chapter 2. Because we were talking about, if something is, so this right here would be a negative skew, right? Because if it skews negative, there's few in the negative. If it skews positive, it means that there's few in the positive, which is what we see here. All right, so we got these two different kinds of skews. So the skew here can affect where the central tendency is located in that data set. Now, if it's a perfect distribution, it's a normal distribution, and this is kind of the shape of the data that we are going to assume most of our data follow. And if that does, then you're lucky because your mean, your median, and your mode are all pretty much going to be roughly right there smack dab in the middle. And so they're usually the same value or close to it. So like in the case of IQ scores in the United States, that follows a normal distribution. So the mean IQ is 100, the median IQ is 100, and the mode of IQ is 100. But a lot of times data deviates from that, so if there's left skew, that mean is going to be much lower than the true center of that data set. It's much lower than the median and the mode. If it skews positive, then you're going to have a mean that is greatly inflated compared to the median. And we saw that when we talked about income, because income follows a positive skew distribution. So let's talk a little bit about why the data look that way. Not everybody behaves in the same way, and you know this because you've taken some psychology classes, and there's lots of exceptions to any kind of rule when it comes to behavior. That it's hard to predict behavior because people are so different. So that is going to affect our data, right? So lots of things can influence our behavior. It can be our history, so the things that we've experienced in the past. It can be our genes or our biological makeup, or it can be just random chance, so just plain circumstance. And so variability is going to essentially tell us how different our behaviors can be. So if you think about our example with social media, or not social media, but looking at screen time, we saw that not all those values were the same. We had some that were really high and some that were kind of on the lower end of things. And so maybe we want to capture that. We want to explain how much difference there is in our data set. And if we do that, then we're going to say, here's the spread, here's the variability. So central tendency is one way to describe the shape of your data. Another way to do that is going to be to talk about the spread or the variation of your data. So variation is super, super, super important. It feels like it's not as important just because, you learned about mean, median, and mode when you were in 5th grade or 6th grade, right? But variation is super important when it comes to interpreting your data, understanding what it means, or forecasting it, trying to make predictions. So we're going to spend some time talking about this very critical piece of statistics because it's going to come up again and again and again this semester. All right. So one of the best ways to talk about variability and variation is through a value called the standard deviation. Now, the standard deviation is a quick way of describing how flat or how wide your data set are, or your data set is. So the value here, the way to think about it is the average or the mean distance from each of your values in your data set from the true mean of your sample. That sounds like gibberish now that I say it. But if so thinking back to the previous example with screen time, think about the mean screen time. I don't remember it off the top of my head about what it was, but think about the mean screen time. Each of those values in our data set is going to be a little bit different from that mean. The average of those distances is our standard deviation. So the standard deviation is like the mean distance that each of the values in your data set are from the true mathematical mean of all of the data points. So this value is always positive or it's 0. It can't really be negative. It doesn't really, it doesn't really work that way. And if we turn our attention over here to this graph, each of these, so the green, the purple, and the red, they all have the same mean. The mean is 10. But you can see that those three curves look totally different from each other, right? And that's because even though they have the same central tendency value, they all have different variation. They all have different standard deviations. And so the green one has a standard deviation of 1. So the values here don't stray that far from our mean. They don't get that far away from 10. If we talk about purple now, purple we see that there's a bigger spread, that it's not as narrow, that it's a wider spread. And the standard deviation is 2. And so what that is saying is that there are more values that are further away from 10 than up here when we talked about standard deviation of 1. And then finally, if we have standard deviation of 3, you can see how spread out that data are, even though, again, it is a mean of 10. So again, it's like, the center is the same for all these data sets. It's just that how much they differ from the mean, that's what's different between these three different figures. So the larger the value, the further away your data set is from the center. The smaller the value of your standard deviation, the closer most of your data are to that center point. Alright, so here is our good friend, and you are going to be seeing this figure so much this semester because standard deviation is going to come up in almost in every test that we do. It's not going to go away. And so whenever I was in undergrad, I didn't have a good handle on standard deviation, and so the first exam came and went, and I was like, okay, second exam will be better because I don't have to deal with standard deviation anymore. But that's all, it doesn't go away. Like, all of the big formula after exam number 1 is going to incorporate standard deviation, so we got to be careful. We got to make sure that we get this here. Alright, so, and actually I was about to rush through this, but if we look at this formula, you already know how to do this. You already know how to plug all this stuff in. You just don't know it yet, because you know what all these pieces mean. So S, this is going to be our standard deviation. That is our standard deviation. So standard deviation is going to be equal to this collage of letters and numbers. So we are going to get the square root. So we're getting the square root of what's underneath here. So what's underneath here? We're going to take a value, we're going to subtract from it the mean of that sample, and then we are going to square each of those values, and then we're going to add all those values together, because that's what the summation symbol means, and then we're going to divide that sum total by n minus 1, where n is going to be the number of values in your data set. So let me backtrack 1 second. What this means is that in your data set, you're going to calculate the mean. So you're going to get the mean, then you're going to subtract the mean, subtract every single value in your data set from the mean. You're going to square it, and then you're going to add it all up. And then you're going to divide all that by n minus 1, and then you're going to get the square root of that. Sounds like a lot, and it is a lot, but you're going to get used to it. It's going to be very familiar to you, an old hat. You're going to know it like the back of your hand because you're going to practice it so much. Alright, so the first steps here, if you're going to be calculating your standard deviation, is the first thing you want to do is you find the mean. So you're going to find the x-bar for your data set. Then after that, you're going to subtract each of the values in your data set by x-bar, by the sample mean. Whenever you're done with that, you're going to square all of those resulting values. Then you're going to add all of them up, and then you're going to divide by the sum of n minus 1. And then you're going to square the result, and that's all you got to do. So let's look at this as an example. So we are developing a treatment plan for a client that has OCD, and we want to come up with a treatment plan that not only reduces their compulsive behavior, but reduces it consistently across the week. So we are going to try this plan for a week with a client, and we're going to compare it to our old plan. So essentially we're looking at the same participant for 1 week and then for a separate week. So plan 1 versus plan 2. Alright, so which plan is better? There's a lot of ways that we can answer that based on what we just learned. So one way that we could do that is by looking at the mean and comparing the two means, which is fine. But in this case, because we want one that looks at consistency, that we really want something that's consistent, then we actually want to look for the variation. We want to look at the spread. We want to look at the standard deviation and find whichever one has the lowest value, because that's going to be the most consistent one. Alright, so let's say that we're going to calculate plan number 1, the standard deviation here. So here are those scores. So if you wanted to, and actually this would be awesome practice, is if you decided to pause the video now and try to analyze the standard deviation for this data set for plan 1. So try that. There are 7 numbers. See if you can do it. Go ahead and pause it and try it out, and then we will work through it together. Okay, so if you paused it, good on you. If you didn't, if you're just like, I'm so lost, I just want to try to watch you do it, Professor, please just do it, and then I will figure it out based on your examples. Both learning styles are fine. Alright, so let's look at this. So we got, and I'm sorry if my big fat face in the top right hand corner cuts this off. You can find all these slides online in Plato if any of that stuff gets blocked, and some of it will. Alright, so for plan 1, we have the different days, 1 through 7, and then we have the scores. So the first thing that we want to do is we want to get X bar. So what is X bar? X bar is going to be 28 plus 22 plus 21 plus 26 plus 18 plus 12 plus 20, which is going to give us 147. We're going to divide that by n, which is 7, and that is going to give me 21. So for this column right here, I'm taking this value, 28, and I'm subtracting from it 21. And it's going to give me 7. And I'm going to do the same thing here. It's going to give me 1. Same thing here. It's going to give me 0. Same thing here. Same thing here. Same thing here. Same thing here. I'm going to be subtracting all the way down. And it's going to give me this. We call these the residuals. The residuals is how far that score is from the mean of your data set. The next step then is we're going to square each of these. So I'm going to square each of those values, and that's going to give me now 49, 1, 0, 25, 9, 81, and 1. I'm going to add all those together. So basically, if I add all that together, sorry, I keep hitting the microphone, it is going to go into this part right here. So everything you see on the screen here is this piece right here. We're adding up all the residuals and squaring them. Or we're getting the residuals, squaring the residuals, and then adding all those up. So that gives us 166, and we're going to divide that by n minus 1, and that gives us 6. So that means that our standard deviation is about 5.26. Okay, great. We're going to do the same thing now for standard deviation, for plan number 2. So here, again, it's 154. So 154 divided by 7 is going to give me my X bar. And so my X bar here is going to be, oh boy, I have to do long division in front of everybody? Isn't that like everybody's worst nightmare? Alright, it's going to be 22. So that means I'm going to come up here and I'm going to subtract that by 22. Gives me 1. Subtract that by 22. Gives me negative 4. Subtract that by 22, gives me negative 17, so on and so forth. Now, once we do that, we're going to have to square all these. And so you may ask, well, I don't understand, why do we have to square them? The reason for that is because if you just take these residuals and add them up, they always give you 0. They always will give you 0 before you square them. A great way to check your math always is to add up your residuals at this point to make sure you get 0. because that is going to tell you if you got the correct mean and if you subtract successfully across all of them. If this gives you something that is not 0, then you may have made a mistake and it's time to back up and look, or it may have been a rounding error. You know, if it's really, really small but not quite 0, it may just be a rounding error that you made. But here, even in this previous example, you can see that the residuals, they added up to 0 as well. Alright, so now based on this, I'm going to square all these. So 1 times 1 is 1, -4 times -4 is positive 16, -17 times -17 is positive 289, and so on, and that gives me 57. Now I mentioned that standard deviation can never be less than 0, and that's because we're squaring all of these, and it gets rid of the negative, so you can never have a negative here. Alright, so we're going to do the same thing here. We're going to plug that in right there. So we're going to do 5700 divided by n minus 1, which is 6, and we're going to get the square root, and that gives me 30.82. So if I'm looking at these now, there are a lot of different ways I can analyze this. One is to get the mean, and if I got the mean, it looks like plan 1 seems to be better, right? Because plan 1 has a slightly lower value here. Okay, cool, but plan 2 has a much higher, has almost the same mean, but has a much higher standard deviation rate. And that's because we have this one value right here. This one value is really changing the consistency rates here. The standard deviation is much higher for plan 2 because we have this one extreme value that deviates so far from the mean value. For plan 1, you can see that it doesn't really stray that far from 21, right? Because that's our mean. Most of these values are within spitting distance of 21. But for 90, 90 is really far away from 22. And because of that, it gives that a much larger standard deviation. Just like 5, 6, and 5 are also really far from 22. So we have those extreme values that are inflating our standard deviation here. Now, if we wanted to get the population standard deviation, it's slightly different here. What we're going to do, there's actually a separate symbol as well. This symbol is that we see here, which is a lowercase sigma. It drives me crazy because this is sigma. It has nothing to do with adding stuff up. It's just completely arbitrary. Here, sorry. Here, the biggest difference besides the symbol is that the denominator right here is just going to be n. It's not going to be n minus 1, it's just going to be n. And the reason for that is a little bit complicated. It's something that's maybe more complicated than what you need to know for an undergraduate stats class. But basically it has to do with the way that we are estimating the amount of variability in that data set. So whenever you are estimating it, you're doing this for a sample, then you're going to do n minus 1. But if you're doing it for a population, you know all of the values that are in the data set. That is you can just find it by using n. N minus 1 degree ensures that it is unbiased, and that has to do with something called the degrees of freedom. The degrees of freedom we'll talk about later in the semester, but the degrees of freedom is basically saying, like, you can change up any value in this data set except for one, and that is the mean. The mean has to stay the same. But yeah, we'll talk more about that later. And even so, it's more complicated than what we needed to get into. All you need to know is that when it's a sample, is n minus 1. Variance is also another way of describing the amount of variability in your data. And all you have to do there is that same formula, but you're not going to do the square root at the end of it. So previously we had this, right? But for variability, for variation, for variance, we just get rid of the square root symbol in that. Sorry, couldn't erase it. And then that is going to give us the variance. It's not, it's really a matter of preference which of those you use. If you want to use the variance or standard deviation. Most sciences are interested in the standard deviation. That's what they are going to be using there. And S2 is the way to symbolize that, which is not very creative. You know, it's just S squared. Alright, there are other ways to measure spread as well. One is the range, and the range is whenever you subtract the highest value with the lowest value. So you find whatever the largest value is and the smallest value, you subtract it, and that is going to be your range. Again, probably familiar to you. You've probably done that in other classes before. And there's also the IQR, or the interquartile range, and that is going to describe what the middle 50% of the data are by telling you what Q25, Q50, and Q75 are. So that is going to tell you where most of your data, the middle 50% of your data, where it resides. And then finally the sum of squares, and the sum of squares is going to be the numerator in that standard deviation formula, which you may remember it looks like this. Looks like that. So if we're talking about sum of squares, that is just that top part there. The sum of squares, we're gonna, again, that's another thing we're gonna be using a lot this semester. It's part of the standard deviation formula, but that is where it comes from. But that is also another way that people talk about measuring the spread of data. Alright, thank you so much for tuning in. I'm going to make one more video where we basically are going to come up with a random data set and work it all the way down to the end. So calculating the mean, the central tendency, and then getting the standard deviation. Alright, thank you so much for tuning in. I will see you later. Bye.